Good morning, everyone. This is Bremster, and I'm coming to you this morning with another puzzle. It's not quite in the solving my own Sudoku range. This is a solving our own Sudoku puzzle. This is a puzzle that I created with Sotek. It came when I sent him a puzzle idea that I'd had using arrows as the break-in. And I wanted to do a particular trick, and I kind of remember the opening break-in trick. This is a puzzle we created about a month ago. We posted to the Cracking the Cryptic Discord server, and we kind of forgot about it. And someone asked us about it recently, and we're kind of dragging it out. So we and I sent it to him, and it didn't quite work. The puzzle, like many puzzles, when you first create it, the idea might be good, but the execution isn't. And we workshopped it for about, I don't know, 3 or 4 hours. By the end of which, it was no longer just my puzzle. The original idea was based on one of mine, but we contributed so much between the two of us. This is a co-creation. This is a puzzle by Sotek and Bremster. So I'm bringing a solving our own Sudoku puzzle. There will be links to this puzzle below. I think this puzzle is probably a 4 out of 5 for difficulty. I could be wrong about that. I think the break-in is a little tricky. There's a couple of things that you need to find, after which it's just a nice arrow Sudoku as far as I remember. So I'm going to take you through this puzzle. I do remember a couple of the tricks from the break-in, but after that, I've really no idea. As I said, it was about a month ago. The links for doing this puzzle will be below. I'm going to post this to Logic Masters Germany as soon as I've created this video, so I will post a link to that as well. And I hope you enjoy the video, and I hope Sotek is happy with what I'm doing for our puzzle. Hopefully I won't mess it up. He's a much better solver than I am. So, the rules for this puzzle. So, in this puzzle, normal Sudoku rules apply, as is so far everything I've done. So in every box, in every row, and in every column, the digits 1 to 9 must exist without repetition. Also, in this grid, there are, you can see them right here, there are arrows. The digits that you place on the arrows will be summed up and put into the circle at the end of the arrow. So, for example, if this was 1, 2, and 3, then into this little circle you must put a 6, because 1 plus 2 plus 3 equals 6. And that's how arrows work. And they're all the rules we get in order to solve this Sudoku. I hope you give it a try and then come back and watch the video and then give it a thumbs up. And if you want to see more of this stuff, join my channel. Let's give this a go. As I said, I do remember the break-in a little bit, so I'm going to talk about that. So the first thing we're going to do is normal arrow trick. Any arrowhead which has a 3-cell, 3-long arrow where all of the cells on the arrow can see each other, because as you saw in my example, 1, 2, 3, they sum to 6. These arrows here must be 6, 7, 8, or 9, because all of them have arrows that are at least 3 long that can see each other because they're all in the same row. Now, these 2 arrows are actually more limited than that, because the only way to make up 6 on an arrow is with 1, 2, and 3. And if we were to put 1, 2, and 3 onto both of these arrows, we would have 4 cells in box 2 that would have to be made from just 1, 2, and 3. Does not work. That can't be 6. The same is true down here. 4 cells that would have to be just 1, 2, and 3. 7 can only be 1, 2, and 4. So the same thing applies. Those 4 cells would have to just be from 1, 2, and 4. Does not work. Whoops, that's not what I meant to do. I meant to do that, and I can do the same down here. So these are just 8 and 9. I'm now going to jump away from this and explain something else, because what people may have seen in this grid is that shape. And that shape will be familiar to experienced solvers, but it will possibly not be familiar to people who are not so experienced, so I'm going to jump away and explain what that shape means. So this is a blank grid, in case you didn't recognize it. And what I'm about to explain to you is Fistomaphel's ring theory, I believe is what it's called. And what I'm going to show you is that those cells plus contain exactly the same digits as those cells. If you are very familiar with this, just jump forward until you do not see this grid on the screen anymore. When you see the other grid, I'm done. So how am I going to... So yes, these 16 digits in blue have exactly the same digits in them as these 16 digits in green. And there's a couple of different ways of proving this. I will use the way that I am most familiar with, even though apparently it's not the most elegant, which is if we highlight the 4 corners of the grid. Actually, I'll do it this way first. If we do highlight those... No, I am going to do the 4 corners. I'm sorry, I am struggling a little. If we highlight the 4 corners of the grid, and I'll put those in blue, what we know about those 4 boxes in the corners is each box in a solved Sudoku grid will contain the digits from 1 to 9. So in those, there'll be 4 sets of the digits from 1 to 9. And by that I mean there'll be 4 1s, 4 2s, 4 3s, 4 4s, all the way up to 9. So there'll be 4 each of those digits. And what we do is we call those 4 sets. And this is called set theory. I am now going to highlight a different 4 sets of the digits from 1 to 9. And I'm going to highlight that as one set of the digits from 1 to 9. That is a different set of the digits from 1 to 9. This is a different set of the digits from 1 to 9, but those 2 cells have been counted twice. And this is a different set of the digits from 1 to 9 with those cells counted twice. And what I mean by counted twice is when I counted that, and then that, and that, these cells in those 4 positions are overlapped. So they're counted in both that set and that set. So this is a set of 1 to 9, this is a set of 1 to 9, but that digit exists in both. So what I've ended up with here are 4 sets of the digits from 1 to 9. So blue is 4 1s, 4 2s, 4 3s, green is 4 1s, 4 2s, 4 3s, all the way through. But the green ones, these are doubled. So if this was the 1, this would be contributing 2 of those 4 1s, for example. Now, if we were to remove one of the digits that was in, or a digit that was in both one of these cells, which exists equally in both sets, then we've removed exactly the same digit from both. So if we have 4 1s and this was a 1, and we remove a 1 from both of them, we've still got exactly the same digits. We have 4 of all of the other digits, and we've got 3 1s in each set. So what we can do is we can highlight all of these cells, and we can remove them. And we still have exactly the same digits in each set. Now these are a single blue and 2 green, which means I can remove a blue and I can remove the double counting of green, and we still have exactly the same equivalent set. So what we've just shown is if you do all of that little trickery, you have these 16 cells are exactly the same digits in the grid in any Sudoku grid that is using these standard boxes of those cells there. So whatever appears in those 16 cells on the outside must appear exactly in this here. And this becomes important in my other puzzle, and I'm about to jump back to it. Welcome back everyone who skipped over the Fistomaphel ring explanation. So when we use the Fistomaphel ring to look at this puzzle, what we can see is in these 3 cells, we're going to have 3 high digits. So there must be, and this is something we have to keep in mind for a fair bit of the break-in, these are going to either be 8s or 9s, this is going to be an 8. But into a lot of these cells, those cells and those cells, we cannot place 8s or 9s because you cannot put 8s or 9s onto a 3-cell arrow unless it's bent like this, and these are not bent. So if you were to put an 8 into here, these would have to be 2 1s at the minimum, which you can't do. So 8 1 2, 8 1 2 sums to 11, and you can't put 11 in here. So you cannot put 8 or 9 into any of those. You can't put 9, you can't even put them onto a bent arrow for an 8 or a 9. So these cannot be 8 or 9. So we must get at least 3 8s or 9s into these cells here. Now, if one of these was a 6 or a 7, you have discounted 8 or 9 from the entire arrow set, which means you would have to get 3 8s or 9s into a single arrow set, which means even if you went 9, you'd have to put 2 8s on it, and 8 plus 8 does not equal 16. And that's if you just put a 6 or 7 into either one of them. So you can take 6 or 7 out of both of those arrows. They just cannot be 6 or 7, or you will break the set that was shown. So these must be 8 or 9. I'm going to remove the ring because it is visible with the arrows, and we will come back to it a few times. The next question I'm going to ask is about column 3. And where can 7, 8, and 9 go? Because we've already shown that if you think about 7s as well, 7s cannot go on a 3-cell straight arrow because 7, 1, 2 sums to 10, and that's too high. So 7, 8, and 9 can only go into those 4 cells because these are all on 3-cell straight arrows. And this arrow here can only take one of them, because if I was to put 7 and 8 on here, that's 15. That can't be 15. So these cells here must be from 7, 8, or 9, and I must put one of them on here, and it either is 7, 1, 7, 2, or 8, 1. This cell can't be an 8. This cell can't be an 8. So this is what we get as the limitation for those cells. Now, we can actually take this a little bit further. I'm going to remove the highlighting again, just for my own sake. What happens if we make that an 8? If this is an 8, this becomes a 1 to make this a 9. But the important thing is we've made this cell here a 1. If we make this cell a 1, this becomes a 9, which is fine, but we can no longer use a 1 on this 3-cell arrow. So this becomes 2, 3, 4, making that a 9, which is okay. But if we also have a 1 in this box, which makes this a 2, 3, 4, and all of those blue cells have to be 2, 3, and 4. And we've got 4 cells that have to be from 2, 3, and 4 in the same column, and that does not work. So we cannot put a 1 into this cell, which means we cannot put an 8 into this cell. And that means that we've only got one spot for 8 in the column. This becomes a 9. And we're down to this situation. Now we can still put a 1 here with a 7 at this point. And that's a bit of a hint. This becomes a 9 as the only place left in the column because 9 can't go on an arrow. And we're left with this situation. Now we need to go back to the Fistomaphel ring and think about the ramifications of these 3 cells. And I admit this break-in is a little bit tricky, but there you go. Now we now have a 9 and an 8 that we must get into the ring. We cannot put a 9 or an 8 in those cells. We cannot put a 9 or an 8 into those cells. We cannot put 9s or 8s into those cells. Now, if we make this an 8, that's fine. That will discount that 8. No problem. So if this is an 8, those 2 cells are negated. So I'm actually going to change those to yellow. They're done. And now we still need to put a 9 and whatever this is onto that arrow there. So this will become a 9. And that's if this is an 8. However, if this is a 9, sorry, I'm a bit all over the place. If this is a 9, then that cancels out that 9, and we still need to get these two cells onto this arrow. And if they were both 8, you would have 8 and then 8 and something on the arrow, which doesn't work. So whichever way you do this, this has to be a 9. Once you turn around and say this has to be a 9, we've now got a 9 that discounts that. So those two cells can be removed from the equation, and we've got to get one of those two cells and that cell equaling these two cells. So we need to get this and this into here. Now, if we make this an 8, that's fine, but we then need to get an 8 or a 9 into there, which means this becomes 8, 1. If this is a 9, then we need to get an 8 into there, which makes this 8, 1. Either way we do this, we've got an 8 that we need to get into those cells. This becomes 8, 1. We can now remove the highlighting, because once we've got 8, 1 in here, we've got a 3-cell arrow. We cannot put a 1 on this 3-cell arrow. Any 3-cell arrow that sums to 8 requires a 1. This is forced to be a 9. This is forced to be a 2, 3, 4 arrow. Once this is forced to be a 9, we've got 2 9s in here that need to go onto this ring. There's only 2 cells that are on this ring that can possibly take a 9. This becomes a 9. This is not a 1. This is a 2, 7 arrow. And we've now resolved whether there was a possible 1 on that arrow. That's tricky, I admit, but that's how you can break into the possibilities of how that works. Now, if we look at this, this needs to be a 9 arrow without a 2. There is only one possibility for that. This is a 1, 3, 5. And that leaves 4 and 6 for those arrows. That's the bit of this puzzle that I remember. Everything from here I haven't looked at for over a month. And I remember that because we spent a long time figuring it out and figuring out whether it was good. Yeah, jury, I suppose, could still be out on that one, but that's how you break into Sparbath. So the next thing I'm noticing is these arrows. 9 with a 4 on it must be 2, 3, because 2, 3, 4 is the only 9 arrow that's got a 4, and anything with a 6 is 1, 2. Either of those had a 2 on it. There's another 4, 6 down here. So this is either 1, 2, 3 and must have a 2, which means that's a 7 and that's a 2. That takes 2 out of there. I can't use 1, 2, 3 or 4 down here, so that becomes a 5 or a 6. This therefore must be either 1, 2, 6 or 1, 3, 5. Either way, there is a 1 on that arrow. Means I cannot use a 1 on this arrow because the 1 is taken up down here. So if I cannot, and I cannot put a 1 here, so this becomes a 2, 3, 4 arrow. This is a 1, 2, 3, 4 quadruple, which means the 4 must go there, and I can take the 4 out of there. There must be a 4 in there. I cannot put an 8 on a 2-cell on an arrow. 8 can't go there, 8 can't go there. This must be an 8. 8 is in one of those two. 9 in this box can't go in any of those because they're on arrows. Can't go in that column. Can't go on the arrow. It must be in one of those two. I can do the same over here. 9, 9. So 9 is in one of those two. 9 in the central box isn't limited. 8 is in one of those 2 cells because of that 8. 8 is in one of those 2 cells. Okay, 9, 9. 9 is forced up there, but 9 is forced into one of those 2 by it not being able to be there. So 9 can't be there or there. That becomes the 9. That is putting a lot of pressure on these cells because they can't be 1, 2, 3, 4. They are 5, 6, and 7. I can't put a 7 on a 3-cell arrow, so this becomes the 7 because there's now a 5, 6 pair. We've already determined down here that a 5, 6 on a 9 arrow must be with 1, 2, 3 and must contain a 1. If it must contain a 1, that's the 8 and that's the 1, and that's not the 8. So there's a lot of nice little arrow tricks with this, but the break-in is definitely the bit that I feel is the most tricky. I've done a lot of arrows recently, which might be why although I'm feeling a bit stuck now. So I can't put 2 on this arrow. So if I can't put 2 on, and I can't put 2 there, so this, similar to what I did with the 1 down here, this has to be 1, 3, 5 because I can't put 2 in those cells because of it, the 2 limitation down there. So this is a 1, 3, 5 arrow. This is a 1, 3, 5 arrow. This is now 1, 2, 3, 5 quadruple. So 1, 2, 3, 4, 5, 6, 7. Which takes 6 out of there. That makes that a 5, that a 6. That makes that 1, 2 to make it 1, 2, 6. I can take the 2 out of there. That becomes 3, 4, which makes that 2, which takes the 2 out of there. That becomes 3, 4. 5 has to go with 1, 3, because 5, 1, 3 sums to 9. 1, what's missing from this row? 1, well, it's 2. That's a 2. Can I do the same down here? I remember this puzzle being a bit symmetrical. Well, that has to be a 7, surely. Because I can't put 7 in there, and yeah, that's a 7. So now I can do this. So 1, 2, 3, 4, 5, 6, and 8. That can't be 8 because of the 8 up there. That makes that a 4. To go with 4, I can't use a 1. It's 2, 3, 4. So missing from this row is, it's easy, it's a 1, wherever I start. So we now, that 1 is looking up, making that a 3 and that a 1. That 2 is looking down, making that a 2 and that a 3. These are now 1, 5, and 6. That can't be a 6 or a 1, that's a 5. So I can take the 5 out of there. This is a 1, 6 pair. 1, 2, 3, 4, 5, and 8 are in there. So this is 1, 2, 3, and 4. The 3 is looking down, making that a 4 and that 3. Can I do similar up here? Or have I broken the symmetry? That 4 is looking up, making that 6. This becomes 1, 2, 6 to sum to 9. I can take the 1 out of there. This is 3, 5, which means that has to be the 1. I can take the 1 out of there. These 4 cells are 2, 4, 6, and 7. I can't put a 2 in there or a 6. This is a 4, 7. I can take 4, 7 out of there. This is 2, 6. That does not seem to be resolving, but 1, 2, 3, 5 go in there. That's resolved by the 3 in box 7. 1, 2, 3, 4, 7, and the 4 down there resolve them. That becomes a 7, and that becomes a 4. Okay. Now I think it's time for us to look at these arrows. And I'm going to start with this one because it's got a 9 looking at it. So what can this sum to? Well, it can't sum to a 1, 2, 3. It could, I'm going to put 4 in as a candidate. It can't be 5, 6, 7, or 8. So 4, 6, 7, or 8. So if this was to be an 6, this can't be a 6, because if this was a 6, then these would both have to be 1 for this to get to its lowest total. And I can't do 6, 1, 1 because that would put 2 1s in the box. So this can't be a 6, this is a 1. That's what I meant to do. So this is a 6, making that not a 6. Now, to get to 4, these need to be 1 and 2, and I can't do that, so that's not a 4. To get... Now, I've got 2, 3, and 5 taken up, so I can use a 1. The next digit I can use is a 4. And the next digit I can use is a 6. So if I don't use a 1, I've got to put a 4 and a 6 on this arrow, which blows the total. So I must put a 1 on this arrow, and it must go there. So what I've got now is 2, and I've got to get to 7 or 8. So this is 5 or 6, and it can't be 5 because of the 5 already in the column. This is a 6. This is an 8. That makes this a 4, 7, and these are 4, 7, and 9. I think that's as far as I can take that. Now I look over here. So this one seems to be a lot more free, although if that's 6, I can't use a 1 in here. So if this was a 6, this would have to be at least 2, 5. Yeah, that's not going to work. This is a 2. This is a 6. So I've got a 2 here. I can't use a 1 in here. The minimum I can use in here is 2 and 5, because I can't use 3 and 4. 2, 2 and 5, well, 2 and 5 sums to 7. That gets me to 9, so I have to use 2, 2 and 5. That's 2, that's 5. That gets me to 9, and that arrow is resolved. That 5 makes that a 3, which makes that a 5. That 3 makes that a 4, which makes that a 3. That 4 makes that 7, makes that 4, makes that 7, takes 7 out of those. These, well, that's a 5, 8, but it can't be 5, so that's 8, that's 5, that's 8. This is 6 and 7, which does not seem to be resolved. That 9 is making that 4 and that 9. That 7 is saying that's not 7. I'm thinking it's now those arrows, because I'm now just working in this the central 3 columns. So 9 can be made up of 8, 1, and that's the only way I can do it. 7, 2. I can't do 3, 6. I can't do 4, 5. So they're the only possibilities. That gives me a 1, 2 pair, which doesn't actually do much. Okay, let's look at the... actually, we've got a 1, 2, 9 across here. And that can't be 9. So there's a 9 right in the middle. And if that's a 1, 2, then this is also a 7, 8. And it can't be an 8. So that's a 7, that's an 8, which means that's the 1, that's the 2. That 7 makes that 6, that's 7. The 7 takes 7 out of there. That forces 7 into there. Let's look at these. 1, 2, 3, 4, 5, 6. That gives me a 5, 6 pair in the column, making that 4, that 6. The 4 makes that 3 and that 4. The 2 makes that 1 and that 2. The 2 makes that 1 and that 2. The 6 says that's not 6. It's also not 8. That's 5. That's 6. That's 8. That's 5. That's 6. The 5 makes that 3 and that 5. And now we're just finishing up. 1, 2, 3, and 4. And that finishes the puzzle. So The trick that I really wanted to come up with for this puzzle was using the Fistomaphel ring in a different way. So what I tried to do with this puzzle was, as you saw on the break-in, have the Fistomaphel ring putting pressure on those arrows because of the digits that you had to put on the arrows and the way you had to figure it all out. I believe there is a way, from some of the feedback I've seen, of doing this puzzle where you can sort of figure out the options on the arrows and they will cause conflicts with each other without using the trick of the Fistomaphel ring to figure out what the options are, and they will sort of put all of that pressure on in a different way. But I did want to have something where that Fistomaphel ring provided you with that extra information. It was just me playing with that idea, and I think it turned out to be okay. I hope you liked the puzzle. I hope you liked the video, and I hope you come back for more. Please feel free to jump on the Cracking the Cryptic Discord server and let Sotek know if you like this puzzle as well, or just drop it in the comments. I'm hoping that he will pay attention. Please, yeah, do that. Thank you for watching, and I hope to see you on another one of my videos soon.